Okay, so let's write a discussion and conclusion. In my discussion, I don't want to just write general comments. I want to give explicit information. I'm going to evaluate and I want to make a claim about accuracy, validity, reliability, and base that on evidence and be explicit about that evidence and then give reasoning for it. And my main discussion is going to center around the graph and compare that to this information here. So the first thing I'm doing is describing the graph, that it produced a linear trend line, which had an equation of this. Okay, now I'm going to interpret what this is. So reading the equation, I'm saying that the results show that the internal resistance is 2.99 ohms and the open circuit voltage is 6 volts. Now I can just add a little bit of detail to say that I can relate this to the graph. Okay, so I've just added that the gradient is 2.99 and that the 6 volts is where the trend line crosses the y-axis. Okay, so that links it to the graph and to the equation for the straight line. As we know, the general form is y equals mx plus b. I'll do a really brief evaluation of accuracy, reliability, and validity. In terms of reliability, using this virtual lab, there's no point in repeating because it's going to consistently give us the same values. I don't think there's going to be much random error, if any, but in reality there will be. So that's when we do it in the lab, we'll actually repeat these and be able to compare the values to each other and to an average. But I guess we can look at the graph and look at the plots, and the plots are fitting exactly on the line. So we would say there's no random errors going on here. It's pretty reliable. In fact, it's pretty much perfectly reliable, only because it's a simulation. In terms of accuracy, well, accuracy is determined by how close your measured value is to what's expected. Well, we manually set the internal resistance to 3 ohms, which is something you can't do in reality, but we have a known value, in this case, that we can compare our experimental value to. The experimental value was 2.99, rounded up, it'll give us 3.0, so that's pretty high accuracy, okay? The other thing that we can compare is the voltage. Now, we actually, at the start of the investigation, and something we will do when we do the actual investigation, is we measured the open circuit voltage beforehand. It gave a measurement of 6.0 volts. Our line, where it crosses the y-axis, was pretty much on 6. So again, that's indicating that we've got accurate results, and also our investigation is valid. We were able to control any variables to produce a valid investigation. So I'm just going to summarize all that here. So here's my brief statement about reliability. I've made a claim that it's highly reliable. I've given my evidence that the plotted values fit perfectly to the trend line, and I've added a bit of reasoning here in terms that because the investigation was done using an online simulator, there are no random errors affecting the measurements. In terms of accuracy, I'm making a claim that it's highly accurate, and I'm giving evidence that I'm showing the measured value and I'm comparing it to the known value, which was manually set in the simulation. Again, we can't do that in reality, so making a claim towards accuracy when we do it, we can only make a suggestion that if the investigation was valid and we get a value, we can suggest that that value is a good estimate of accuracy rather than saying how accurate it actually is, because we won't know what the true value is. And my last brief comment about the validity. So I'm making a claim that the investigation is valid. And in this comment, I'm saying what I'm using to judge validity in terms of variables being controlled. And the evidence that they have been is that the open circuit voltage that was measured where the trend line crossed the y-axis, well, that's exactly as was expected, because we set the battery to 6 volts, and before we connected it, we measured the open circuit voltage. So now I'll just finish with a conclusion. So I'm just going to refer back to what was the aim of the investigation. So I'll start with this. The aim of this virtual investigation was to determine the internal resistance of a 6-volt battery using the graphical method. And then I'm just going to briefly say what my results were, and that's pretty much it. So I've made my statement about restating what the results were, and that it agrees with the expected value. But in reality, we don't know what the expected value will be. So we will deal with that in a different way. And that's it.